An example of how different physiochemical properties affect where different gelatinous zooplankton are found. The ocean is a dynamic realm where physiochemical properties dictate the distribution of fascinating marine life. To explore this, we are going to be looking at two vastly different gelatinous zooplankton species, one found in surface waters and one found in the deep. Physalia physalis are found in the epipelagic zone and prefer open ocean surface waters. Benthicodon hyalinus are found in the hadal pelagic zone and inhabit the deepest parts of the ocean, including trenches, seamounts, and abyssal plains. Let's begin by comparing how temperature influences the distribution of Physalia physalis and Benthicodon hyalinus. Physalia physalis prefer warmer surface waters, with temperatures typically ranging from 20 degrees to 28 degrees. They are sensitive to cold temperatures and may not survive in cooler waters. Benthicodon hyalinus, however, thrive in cold temperatures. The deep ocean is usually near freezing, between 1 to 4 degrees, and they are adapted to withstand these cold conditions as they often have a much lower metabolic rate compared to surface-dwelling species. This adaptation allows them to conserve energy in environments where food availability may be limited and metabolic demands are reduced in cold temperatures. Benthicodon hyalinus depend on limited food resources in the deep ocean, including detritus, small planktonic organisms, and potential prey associated with deep-sea ecosystems. Physalia physalis feed on small fish and plankton that are abundant in surface waters and rely on prey items that are readily available in the epipelagic zone. The hadal pelagic zone is an extreme high-pressure environment exceeding 1,000 atmospheres that the Benthicodon hyalinus has adapted to. They possess a highly gelatinous and flexible body structure, typical of many deep-sea organisms. The gelatinous composition allows the Benthicodon hyalinus to withstand extreme hydrostatic pressure without collapsing or undergoing structural damage. The tissues of the Benthicodon hyalinus are also adapted to resist the crushing pressures of the deep ocean. In comparison, the structure of Physalia physalis is adapted to the low hydrostatic pressure in surface waters compared to the deeper ocean zones. Their structure and buoyancy is supported by a gas-filled float, which is adapted to surface-dwelling ecology, where it relies on wind and ocean currents for movement and dispersion. They also have long, trailing tentacles that extend below the float to capture prey and defend against predators. The tentacles are adapted for life in surface waters, where Physalia physalis encounter different ecological challenges, very different compared to deep-sea organisms like Benthicodon hyalinus. To summarise, Physalia physalis and Benthicodon hyalinus represent contrasting adaptations to distinct oceanic environments based on their physiological and ecological requirements. Understanding these differences enhances our knowledge on how organisms can cope under extreme conditions and thrive in diverse marine habitats across different ocean zones.